Hey guys, so I just wanted to go on from my protein video where I explained that a bit more in depth to go to carbohydrates, probably the ones that people want to know about most after protein. So the first thing I wanted to go through is the structure. So a lot of people will say all carbs are the same, so if you have a cake it's the same as having pasta, which isn't necessarily true, which I'll go through in this. So we've got monosaccharides and we've got disaccharides, we've also got oligosaccharides and polysaccharides. So the monosaccharides are single units or individual molecules of sugar, so things like glucose, fructose and galactose. Galactose. Disaccharides are two or more molecules of sugar, so those things like sucrose, which are found in fruit and veg, and that's galactose and fructose mixed together. Got lactose, which is found in any dairy product, so everyone knows about lactose intolerance, and that's just the body's inability to break that down. And that's a mix of glucose and galactose. The last one is maltose, which is two glucose molecules combined, and that's mainly found in grains, so things like rice and oats. They'll be found in them. The next thing is complex carbs, so those were the simple carbs. This is the complex carbs. They're mainly referred to as starchy carbs, so anytime you get pasta or rice, you'll notice the water tends to go slightly cloudy, and that's just where some of the starches come out of that. Contains a large number of monosaccharides, and they form a large chain, so from that our body finds it a lot harder to break it down, which is why they're called slow release carbs as well. The longer the chain, the harder it is to digest, so if we take something like pure sugar, glucose, as opposed to something like rice, it's going to take a lot longer for the body to digest that rice, and so we get a slower blood sugar response. Refined versus unrefined sugars, again, is to do with the quality of it. So the refinement of a sugar breaks down the links within the carbohydrate. So if you get something like a cake or a bread, or white bread usually, they will have refined sugars in, where they've had to break down some of the molecules to make it sweeter, whereas the whole grain, it hasn't had to be broken down nearly as much, and they usually tend to be unrefined. So I'm going to show you a little diagram here while I'm talking. The digestive process. So the first part of this is the dietary glucose, and that's what we put into our mouth. So that's anything from pasta, bananas, apples, to sugar in your teas and coffees. The next step is when the glucose enters the body enters the blood after it's been digested, and then we come on to the slightly confusing bit for people who don't understand carbs, which is the insulin response, and that's when it's released from the pancreas. So the body senses an increase in blood sugar, and that's not good for the body because we like to have a balance. With that, our body releases insulin, which tells all of our cells to open its gates basically and allow storage to take place. And following this, the next part of the diagram is where it's stored. So we've got liver storage, muscle storage, it's used for fuel as well, and adipose tissue. So that's where it gets converted into adipose tissue and the fatty acids. And the last part is where some is left in the blood for the brain. So the brain needs energy as well, and it's not a storage area, so it needs to be kept in there until it reaches that area through the circulation. So insulin, just like I've explained, is what tells our body to uptake sugars or glucose into the muscles or its storage areas, or whether it needs to be used. So again, I'll go to another diagram showing the process that insulin goes through, and it's basically simplified as blood glucose elevates, insulin is released, and then as insulin is released, the blood sugar drops as it's been entered into the cell, and there's not as much left. So the next thing is glucagon. That's pretty much the opposite hormone to the insulin, and I'll go to another diagram. Blood glucose decreases, so we need to get sugar back into our blood to make sure we don't go hypoglycemic, which could lead to fainting, or even worse, it could lead to death. So we release glucagon, which tells our body to open its gates again, but this time instead of letting things in, it's going to release its sugar stores. So that's either in the muscle, the liver, Also, fatty acids can be used though, or ketones, which are brain producers in times of very low carbohydrate states. And then what happens is the blood glucose goes back up, and that helps sustain our blood glucose levels. So the next thing I wanted to go into is something a lot of you have probably heard of, glycemic index, and that's the speed a given carb source enters the bloodstream. So for example, on here I've got 10 grams of glucose has a GI of 100, and that's fine if that's the case. The problem with glycemic index is it doesn't take into account the higher amount of a carb source, and that also dictates the length of time it's in the blood system. So 20 grams of glucose is near enough to 100 as well, but you can see there's double the amount of carbs. If you had double the amount of carbs with anything, if you had 100 grams of rice and 200 grams of rice, the 200 grams of rice is going to sustain the blood glucose response for a much longer time. So the main factors that are going to influence GI that haven't been taken into consideration are the total carbohydrates eaten. So that is what I was just saying there. If we double our carbs, it does have an effect on the blood glucose response. Total fat content. So fat is very good for slowing down digestion because it delays, or is the biggest inhibitor of gastric emptying, and that's where the stomach is emptying its contents into the intestines. The total protein content as well. Protein is harder to digest than carbs as well, and that also slows gastric emptying. The presence of insoluble fibre and the presence of soluble fibre. The insoluble delays gastric emptying, and the soluble fibre slows the absorption of glucose into the blood. So you can see that they obviously have a major effect on it. Cooking methods as well. So heat, you've probably read a lot about it in proteins as well. Heat breaks down the proteins. It does the same thing with carbohydrates as well. So the more complex carbs, if you heat them to a high enough level, they are going to break down and become simpler carbs into their monosaccharides or polysaccharides. The preparation as well, so things like pasta and bread, they are derived from the same thing, wheat, but bread has a much higher glycemic index than the pasta will because of the way it's prepared and the things it's mixed with. So it doesn't take that into account either. So there's a lot of room for change with that. Which brings us on to glycemic load, and the good thing about glycemic load is it does take into account the amount of carbs that are being ingested, and that helps identify the longevity of the blood sugar response. And I'll just show a long table here. You might have to take 2 shots of it. Glycemic index versus glycemic load, and this table shows the difference between the measuring systems. So it shows you the difference between one column shows glycemic index of a food and the other shows the glycemic load. You see this in some foods, there's a correlation. The higher the glycemic index goes, the higher the glycemic load goes. So glycemic index does have some relevance, but glycemic load is going to be much more reliable because it gives us an indicator of how long that sugar is going to remain in our bloodstream, and it's going to allow us to best pick the carbohydrates we need to suit our goals. If we're trying to gain weight, we want it to sustain our energy levels. If we're trying to lose weight, we want to make sure it's out of the bloodstream as quick as possible so we start burning fat again. So the next thing is fibre. So fibre is classed as a carbohydrate because of its makeup, but they are non-starchy polysaccharides, or things like your brands of foods. So these contain no energy because we don't have the enzyme to break it down, so it just passes through our body. And we have 2 types. We have insoluble and soluble. The insoluble is usually the bran of the grain, so you get oat bran and things like that, and that's the harder part of the grain that's going to help us get food through us, basically. It's usually an unrefined rye and rice, anything unrefined that is going to have an outer layer on its grain. Soluble is usually the softer inner part, and that's going to be in things like beans, broccoli, apples, anything like that that has kind of a softness to it. It's not crunchy before it's cooked, as opposed to things like rice. Fibre will help us pass food through our system, so it's going to help you feel. It'll help you feel fuller for longer, for one. It'll help get it through you as well, so you won't feel bogged down quite as much. Soluble fibre helps bind to bile, and what that means in terms of weight loss is that fat isn't absorbed as readily, because bile is the fluid in our body that binds to the fat and carries it through. So if the soluble fibre is already bound to that, there's no fat that can bind to it as well. Fibre helps delay gastric emptying again, like I said, as well, and it also sits within the intestines, which is where the glucose or the sugars are being absorbed from. So if there's something in the way of it, it can't be absorbed as readily. And the last point I want to go through is the quality of the carbohydrates you're eating. So the higher quality will be utilised more by the body due to the higher vitamin content. So that goes on to the next point, anti-nutrient carbohydrates. And these are the ones that are going to take nutrients that your body's already stored, and it's going to have to use them for the digestive process. And over the long term, that can lead to a malnutrition or a decreased amount of these in your body, which means you're not going to be able to digest them as readily, and that means they may go into storage a lot quicker. So I hope this video helped, guys. Hope the little tables help as well. Let me know what else you want to hear about. I'll be doing a fat in a bit more detail, just to round all this off, and I'll try and get a few more videos out. But have a good one, rate, comment and subscribe.